one. How many takes are we going to have?
It's fine.
Okay, so for this team talk, as you were involved with developing our cable materials, thought it'd be good to get some of your knowledge and your insights. So I'm going to start by doing a little bit of a pop quiz, if you like, in that there's so many acronyms that come up with the cable materials.
Yeah.
That I've grabbed some of them, and you can tell us what they stand for. So the first one, don't you see it, is HFFR. So what does that stand for?
So that's the Halogen Free Flame Retardant. Try saying that 3 times fast. Yeah. So halogen free flame retardant. So it means that that particular material doesn't contain any halogens, essentially.
Okay, cool. Second one, LSZH.
Okay, so that's low smoke, zero halogen. So it's a similar grade, but that grade specifically will be developed to have a low smoke output.
Oh, fab. And then third one, I think it goes similar. So LSHF. So
yeah, low smoke, halogen free.
Ah, perfect. I'm afraid there's no prize, but there you go, 3 out of 3. The common theme through all of those is they talk about halogen free.
Yeah.
So what is about halogen? Well, why do we need halogen free materials?
So for that, I think it's best to understand why halogens are bad. Traditionally, legacy materials for flame retardants have been made with things like PVC. Now, the halogen part of that is the C, so I don't know how familiar you are with the periodic table, but there's a group of elements called the halogens, of which chlorine in PVC is one. Now, they are good natural flame retardants, but the problem that you have is the combustion products when it burns. So they are designed to not burn particularly fast, but they will still burn. And it's what is released by that burning process that causes the problems. So the PVC ones, they'll release toxic gases. And in a fire situation, you've actually got more of a threat from the smoke than you have the flame.
Okay.
So if you can imagine you're in a building that's burning, you've got all these toxic gases around you as well. That's actually going to cause these people more problems than the fire itself, because that can just spread so much further. And then the secondary issue that you'll get from that is we use water to put fires out. So if you mix water with these toxic gases, in the case of PVC, you'll get hydrochloric acid. And then that's being dispersed over the area wherever you're using the water. And that can obviously cause damage to people, it can cause damage to property. So it creates a lot more damage than it would if there wasn't a halogen in there creating those toxic gases in the first place.
Yeah. So hence we've got to produce halogen-free flame retardants.
We have, yeah.